In the next couple examples, we'll look at the area between two curves in which the bounds are not given to us. So let's find the area of the region bound by the curves, say y is equal to x squared minus 2x, and the curve y is equal to x minus 2. And we're not given what the bounds are, so we need to find out where these two intersect. I could kind of give a sketch of what these graphs look like. We know that, say, x squared minus 2, right? This is, if you simplify it, x times x minus 2. So I know it's a quadratic, and it goes through the point 0 and 2, and it looks something like this. That's what this is. Y is equal to x squared minus 2x. Similarly, x minus 2 is just a line that goes through negative 2. So we've got, say, negative 2 down here. And when x is 2, it's 0. So it's going to go right through there. And so my line looks something like this. And so I'm trying to find the area of this region here. So first off, we need to know, we actually, from the graph, we can see one of them, but where's the other one? So let's work out where they intercept. So first question is, when is x squared minus 2x the same as x minus 2? Where do they intersect? So solving this, I get that x squared minus 3x plus 2 is 0, which factors into, so I'm going to have an x. I'll have a 2 and a 1, and I need it to add up to 3, so it'll be minus, minus. So now we know that this spot here where they intersect is 1, and this other spot, which we knew already, is 2. So now we know. We want to find the area of the region between these two curves, and we now know that 1 will be less than or equal to x less than or equal to 2. And let's just, for the sake of argument, say we didn't know what the graph looked like. I am completely confident that you should be able to draw a parabola, recognizing that's a parabola with intercepts 0 and 2, and that this green line, right, is the line, slope 1, intercept negative 2. I have no doubt you could draw it, but again, let's make sure that we're good with our algebra. So like before, I want to know the signs of this equation. So I make my sign graph. So this is the sign graph for what function? Well, it's really for x squared minus 2x minus x minus 2. And we know that it changes signs at 1 and at 2. And so picking values in between, if I say pick, say 0, and put it to my function, I've got 0 minus 0 minus 0 plus 2, so it's positive. If I took a value in here, say 3/2, then I could put it into this function, and I would see that it's negative. And then if I took, say, 3, it would be positive. So in between 1 and 2, and that's our range here, in between 1 and 2, we know that, so in between this region, x squared minus 2x minus x minus 2 is negative. So then x squared minus 2x is less than x minus 2, right? So that's exactly what the graph told us, that x minus 2 is in between this region. It is bigger. than x squared minus 2x, but it doesn't hurt us to practice our algebra, determine our bounds of integration. So then the area will be the integral between 1 and 2 of x minus 2 minus x squared minus 2x with respect to x, which is equal to the integral 1 to 2. So I've got an x minus a minus, so that'll be 3x. I've got a minus 2 and a minus x squared with respect to x. And now I can integrate this no problem, so I don't need to separate it. This is equal to 3 halves x squared using the power rule minus 2x minus 1/3 x cubed, all between 1 and 2. So this is equal to 3 halves 2 squared minus 2 times 2 minus 1/3 times 2 cubed minus 3 halves 1 squared minus 2 times 1 minus 1/3 1 cubed. And if you work that all out, you'll see that this is equal to 1/6. So the area between these two curves, this little region, has an area of 1/6, whatever the units are. But that's the area of that region.